all, instead of graphing on the x-y axis, you can graph imaginary numbers if you call the horizontal axis the real axis and the vertical axis the imaginary axis. What's wrong? You don't have any paper.
I already used the stuff here. Send me out the
Merry Christmas. Use this in my class. You better have paper with.
I will. It says Matthew.
Matt Allen. I took his bell work out. One year I bought every student a notebook, and they kept it in here, and we did bell work every day, and I graded it every week, and I made you write. Isn't that terrible?
No, we did that in summer class.
I know. Okay, so what if I was going to graph 2 plus 3i? Right, that's a complex number. There's a real part and imaginary part. Yes?
Yes.
So I would go 2 over on the real axis and up 3 on the imaginary axis. And that would be the point, 2 plus 3i. And, I don't know, do we need to practice another one? Shut up here for a moment. How about I make a point and then you tell me what the coordinates would be? -3 plus 2. What we want to talk about is the distance from the origin to that point. So if I measured like from here to here, oh, maybe, what do I see? Vector, it's a triangle, right? Like all that trig stuff comes right back to us, except for now we're talking about a plus bi instead of a vector, or instead of SOHCAHTOA stuff. But we can say the absolute value of a plus bi is defined as the distance from the origin to that point. Kind of looks like the magnitude that we talked about with vectors, right? And you're going to see very similarly that to find this, it's really just a version of the distance formula. If we're measuring back to the origin every time, the second point is just 0. So just like with vectors, we can say that the distance is the square root of a squared plus b squared. Kind of like the radius, right? Because you're just looking at the numbers part. I don't know why I have another equal sign. I don't have anything else to say about that.
That's all I have to say about that.
Okay, can I go? So let's practice. There's lots of stuff we can do. This is, we're laying the foundation today, kids. We haven't thrown the actual trig in there yet, right? Now give me the calculator there.
Yeah, it's just.
Does that one go over here or over
I
here?
got it.
So I'm not going to make a bunch of marks on my graph here because I can see that I'm plotting 4 minus 2i. So that's 4 on the real axis and then -2 on the imaginary axis. So that would be right here. And then I need you to know this notation, right? When you see that absolute value, it means the distance. And basically means like the radius if we were talking about triangle stuff, or the hypotenuse, or the magnitude of the vector, right? There's so many things we could call this. But this means find that distance from here to here. You don't have to draw that in, but I'm just trying to show you that's what it would be. And it's just the square root of 4 squared. I'm just going to say plus 2 squared, which would be the square root of 20. Do you think I want you to leave it as a square root of 20?
Yes.
Nope. Do you think I want you to give me a decimal?
Yes.
Nope. I want you to break it up and say that that's 2 radical 5. trig is here?
Roadside.
So I drew in some point out here. I'm going to call that a plus bi. I know you're going to tell me that it's really negative a plus bi, but let's just go generic for a minute, okay? And just like always, if I drop down the vertical and connect horizontal, then I have a lovely little triangle here. But instead of calling it x for y, or whatever we called it with vectors, what did we call the vectors? A and B? B1, B2?
Yeah.
I kind of forget. But if this is a plus bi and a is the real part, do you agree that this is a and this is b?
Where's I?
I is just the imaginary part that stays with the imaginary part. Like, we just leave it there.
It's just hidden.
It's hidden. This is that distance, which is the absolute value of a plus bi. But just for easy use here, is it okay if I call this r? Call it really whatever you want. So again, using our reference angle here, right, if I call this theta, what would the cosine of that angle be?
How about sine? A over R. A over.
And what would the sine be? If I wanted to solve that for a, could I say a equals r cosine theta? If I wanted to solve that for b, could I say b equals r sine theta? Does this seem similar to vector stuff that we did?
I feel like we were just saying this, but I don't remember what it is.
I know, we just did this. We were changing
Polar
vector
coordinates.
form to, oh yeah, polar coordinates. Yeah, that was the polar coordinates when we said x and y instead of a and b. It's all closely related, which means maybe it's all going to be very confusing. I don't know. Changing letters.
Just all blend together. Why not?
So if I have a plus bi, could I replace a with r cosine theta? And could I replace b with r sine of theta? Where's the I go? I don't know.
It all equals 1.
It doesn't equal 1. I could pull an r out of here if you want. I usually put the I in front. You don't have to, but r cosine theta plus I sine of theta, if z equals this, then z also equals this. At the very beginning, we said z equals a plus bi.
Oh, yeah, we did.
This is called the trig form of a complex number. Trig form is also called polar form, and maybe you can see why, because this is just like what we did with polar coordinates, only instead of a and b, we called it x's and y's. If you want to throw some other things, this is like your go-to page today. R equals the square root of a squared plus b squared, right? That's our distance. Do we want to write, do we need to write what tangent equals? I don't know.
A over B. No, wait, B over A.
B over a. I don't know that you ever need that, but this is kind of the big thing that you need. So really today what I want you to be able to do is find the R value, but the big thing is I want you to be able to go from complex form to polar form, trig form, and from trig form back to complex form. And then tomorrow and Wednesday we're going to do more stuff with this, like solving equations and expanding and adding and subtracting, multiplying, more fun stuff, right? So again, just a reminder, complex form is a plus bi, and I want you to change that to r cosine theta plus I sine of theta, which means you need to find r and you need to find theta. Can you find r pretty easily? What is r? How do you find r? R is like the distance, right? So it's just the square root of a squared plus b squared. If it helps, you could sketch it, especially depending on what quadrant you're in. We're going to think about that in a minute, so I'm just going to very roughly sketch this out here, right? So I can say r is going to be the square root of 2 squared plus 2 squared, square root of 8, which is 2 radical 2. How am I going to find theta?
Draw a triangle.
You could draw a triangle. Sometimes you can just use your brain a little bit. Use what you know about trig. If I'm in the first quadrant, and this is 2, and this is 2, and this is 2 radical 2, do you know what angle that is? Yeah, that's a 45-degree angle, because if you know the unit circle or you know the special triangles, if the sides are the same value, like that's going to be a 45-degree angle. So if you know that and you can figure that out without doing the work, by all means, that's why we've been learning trig all year, is that you don't have to always do all the work. But let's say you have no clue what I'm talking about when I say that's a 45-degree angle. You can just use what we know about sine or cosine or tangent, and it doesn't matter which one you do, right? We said cosine of the theta would equal a over r, sine of theta equals b over r, and tangent of theta equals a over b. As long as you do it correctly, evaluating any of those will give you the right answer, right? So I tend to just stick with sine or cosine, but tangent might be the easier one to go here. But if I did cosine, I would get 2 over 2 radical 2, or that's just 1 over the square root of 2. That maybe looks like in a circle, which gives me theta as pi force. Does that make sense, what I'm saying there? If it's from the unit circle, I want nice answers, which means if you're going to cheat and use your inverse button on your calculator, don't give me a decimal in radians, right? So, just saying. You get the same thing if you do any of these, right? Be careful. If you're not in quadrant 1, right, make sure that you use the appropriate multiple of pi force wherever you would be. So what is your answer? You just change it to this. So r was 2 radical 2 cosine of pi force plus I sine of pi force. You don't do anything else with it. You're putting it in trig form, and you might say, why in the world would I take something like that and put it in trig form? And we're going to get there in the next couple days, because sometimes multiplying, finding roots, or taking to a power is a lot easier in trig form than it is in complex form, and so that's why we want to be able to do this. Questions about that? If you worked that out, you would get back that answer, right? It's just another version of that. Let's practice another one.
I think you're making yourself sound somewhat positive when you say that. So robotic. Keep drawing.
I got it. No worries. Counting this. Again, you can use some knowledge that you hopefully have about trig to help you on these problems. But what is A and B in this problem? It just says 4i. Right, like, so you could write that as 0 plus 4i. So A is 0 on this one, which means where would that point be?
Right there.
Which means, could you tell me what theta is pretty easily?
Halves.
Could you tell me what r is?
4.
It's is just 4. If you didn't know it was 4, if you do the formula, you would get 0 squared plus 4 squared, which is just going to give you 4. But if it's on the x or the y axis, it's just going to be that number. So 4 times cosine of pi halves plus I sine of pi halves. And just so you know, if you work that out, you do get back that answer. Cosine of pi halves is 0, so you get nothing. Sine of pi halves is 1, and 1 times 4 is where I get the 4i. So don't overthink some of these. They're not that bad, right? What about going the other way? So sometimes they're going to give you angles that aren't in the unit circle, that aren't things you know, and you're going to have to give me decimals. But if they give you something that is in the unit circle, or is a multiple of something in the unit circle, I don't want decimals. Okay? No decimals if a unit circle angle. My angry face.
That looks like kind of scared, maybe a little bit.
It's 225 degrees in my unit circle.
Yes.
Here, is that 225? Yes. If it was something not in my unit circle, like 74 degrees, to work this out, you would just type it in your calculator. You would take cosine of 74 degrees times 1/4, and you would get that decimal. Right? And that's going to happen sometimes too. But if it's from the unit circle, I want you to know that this is negative radical 2 over 2, negative radical 2 over 2. And we could say this is 1/4 times negative radical 2 over 2 plus I times negative radical 2 over 2. Or 1 over radical 2 if you prefer, but I don't ever think that way.
What's the first one again?
That's what the point is here, right? At 225, it's negative radical 2 over 2, negative radical 2 over 2. You just work it out. So you just multiply. When you multiply fractions, top times top, bottom times bottom. So you get negative radical 2 over 8 minus radical 2 over 8. Don't forget the I somewhere. If it's a multiple of pi fourths, the A and the B should be the same value, right? That's how you get a 45, 45, 90 triangle, is that it's isosceles. Question? That's your answer. That's in standard form. Let's do another one.
So you made yourself sick.
What?
Not really excited.
You do this one. 10. No decimals.
Must be it's fun.
There's the English field trip tomorrow, so if you're going to be going on that, just know we are doing notes. We are doing 6-6 day 2, so you need to check in with me before school or after school. I'm probably not printing the notes out tomorrow, so I'll put them online. Check the video, but you are responsible for that. 2 by 3rd. So that would be 10 times negative 1/2 plus I times radical 3 over 2. So that would be negative 5 plus 5 radical 3. I like to put the I in there. Do you agree with that?
Pretty much, yeah.
So you can put the I out here if you want. Here's why I don't like to do this, because sometimes people are really messy and then it looks like the I's under the radical. So I tend to put the I in there. You don't have to, but I just think it saves someone grading it and worrying that you did it incorrectly. So we're just going to build on this tomorrow. Tomorrow I'm giving you 3 different formulas, and then on Wednesday I'm giving you another formula that's really ugly. So you got to make sure you can convert easily back and forth as we go through adding on to this for tomorrow. Thursday we'll review. I'll give you the review assignment, and then Friday we're having the test. So I want to make sure that you see me in the morning that day if you have questions. 4 through 8. 12 through 16, 18, and 67. Mr. Pruitt had a township performance as well. He told time without a watch. He said from his days of running that he could just count time pretty easily. So he took his watch off and gave it to this kid. And he said he was going to tell when 1, 2, and 3 minutes went by. So he stood up there for 3 minutes.
Probably just counted in his head.
Awkwardly. And was like, I think that was part of the thing, was he was just super awkward. He was like, so after 1 minute, he was like, he got 1 minute, exactly right. He was like, 1 minute. And then the second minute, he was off. And then he's like, it's right, I'm going to get it right on the 3rd minute. And he's like, this probably would have been better if I just did 1 minute, right? Because it was just like a lot of awkwardness. And then he was off by 2 seconds.
He probably could just watch the clock.
I know, there's a clock in the back, and that's what I want to say. But he 2:58 is when he stopped it. So.
Probably did awful. I thought we do